In question 24a, we're asked to state Newton's second law. Well, this is force equals rate of change of momentum. You can remember it as F is equal to delta P by delta T, but you'd need to put it into words for this question. In part B, we have a comet making an inelastic collision with a small asteroid in space. We're to state two physical quantities conserved in this collision. Well, mass would be conserved, total energy, not kinetic energy because it's an inelastic collision, and momentum. In part 2, we have a graph a little bit like this, showing the force F acting on the comet varying with time during the collision, whereas to describe and explain how the force acting on the asteroid would vary with time during the collision. Well, basically, by Newton's third law, the force would be equal magnitude and opposite direction. So we'd have a line on the graph going a little bit like this. In C, we have a hydrogen atom colliding with a stationary carbon atom, then both moving off. We're asked to find the speed of the carbon atom after the collision. Well, by conservation of momentum, the momentum before will be equal to the momentum afterwards. And so initially we have 500 meters per second times 1.7 times 10 to the minus 27 kilograms. And afterwards we know we have minus 420 meters per second because it's going in the opposite direction, times 1.7 times 10 to the minus 27, plus the unknown v times 2.0 times 10 to the minus 26. We can rearrange this as 500 plus 420 times 1.7 times 10 to the minus 27 over 2.0 times 10 to the minus 26 equaling v, which gives 78 meters per second.